We're out doing a demo today. That well up there is a real stud. That thing has made a lot of oil, and it's still making a lot of oil. It's on a semi-isolated feature, somewhat round, at least if it's following the 3D. We're going to work our way toward that well and see if we can pick that reservoir up. I'm using my new system that we built. I just designed the new sensor about a month ago, and I built some new hardware and changed some configurations in it, and then at the same time I asked my engineer to write some more code that we use on our LabVIEW software platform. And the reason for that is I wanted less calculations to do myself and make the software do more calculations. Part of the reason we can do that now is that I know exactly what I'm looking for. So the computer's doing a lot more of the work now, and that enabled us also to put this demo screen on here, which is going to be great for somebody that wants to go out and ride with me and see how this thing works, see for themselves that it works, see that I'm not pressing buttons or with my feet or my hands to make these alerts go off. So anyway, I have this meter is really more for the demonstration side of it, but I have this blue arrow here is set to alarm at 3600, which is actually, I'm being a little bit, I probably need to adjust that meter scale a little bit, but if that alarm goes off, basically we're in something good. If it beats that blue arrow, we're in something even better. So being as big a well as that is, I would expect it to do that, but we'll see what happens. Running 2-minute scans. I'm going to go ahead and start the first one right now. I don't think that reservoir extends up here that far. This is a huge development in that this, basically what we have here is a mobile tool that can pick up hydrocarbon reservoirs in real time. I don't know that there's another piece of equipment out there that can do that. Certainly can't do it with seismic, and even if you could, it doesn't tell you for sure if you've got a hydrocarbon in that high. This technology, this HMPA technology, is identifying oil accumulations at depth. It doesn't care how the oil got there, whether it's stratigraphic traps, structural traps, sands that 3D can't see. It really doesn't matter. So it looks like we're probably going to end this scan at 3370, which is a weak hydrocarbon indication. Nothing I would drill. Not totally surprised that we wouldn't have a little bit flaring out this way. Okay, now I'm just going to ease up here just a little bit toward that well. Right here, we'll go ahead and start another scan. pretty exciting development. Couldn't take guys out and demonstrate the other system, the predecessor to this one, because there's too many calculations I had to do, and I have to do those, had to do those back at the office, and there were some proprietary things that I wouldn't want anybody to see. This system doesn't have those issues. I still use both systems. The old system has definitely proven itself, and I'm going to continue to run both systems together when I do in-field surveys, and because I have two data sets to work with, and the systems look at the data a little bit differently, and so the more data you have with these alternative technologies, the better off you are. But I think this one's probably going to be the cat's meow. 30 seconds to go. You're going to hear a funky alarm if we get up there and we detect that reservoir. Just a little something to throw in there for the demonstration purpose. And since I'm a Star Trek fan. The only problem is I can't reset it until it ends, and that's going to get on some people's nerves. So I'm edging up here a little bit. Now I would expect to be getting into the reservoir now. When I do demos, I mean, if somebody wants to back up 1,000 feet, we can do that. Obviously, I didn't go back that far here because this would be an hour video. But we definitely had two readings that were in the weak range. And I'd say we're about 300 to 400 feet from that producer. I think that feature, again, this is, no one knows if the reservoir is following the 3D feature, if the 3D is even accurate, but if it is, the reservoir has more of an east-west lobe to it, and it's not real wide. East to west is, or north to south as it is long east to west. It's working its way up now. We've definitely crossed into something. This is probably going to end up being the highest reading that we're going to get. We'll see if it trips the alarm. I'm going to go ahead and override the timer. The reason that I do that is sometimes I don't get the data in until late in the scan, and if it's still calculating, I don't want to cancel the, I don't want to let the timer time out before this thing's done calculating its final result.
Hydrocarbon reservoir detected. Hydrocarbon
And that there is what we are looking for.
Hydrocarbon reservoir detected. Hydrocarbon reservoir detected.
I will silence that alarm.
Hydrocarbon reservoir detected. Hydrocarbon reservoir detected.
That is a robust signal there, which I'm not surprised with the strength of this well. So we're definitely in it now. So it looks like 3730 is going to be probably, well, it'll probably climb all day, but we already know we're in it. So I'm gonna kind of drive around this well, get a couple more readings. it right up to the pumping unit, and the reason for that is that, and it took me a little while to figure this out, but those pumping units are a big chunk of iron with a 4,000 foot ground rod going all the way down to water and salt water and who knows what else, the ground rod being casing. So that pumping unit is zapping my signal. Fortunately, that phenomenon only exists about 100 to 150 feet around the pumping unit, and I'm starting a new scan here. After I get outside of that radius, that phenomenon dies off, and I think we're out of that now. We'll see if we can trip the alarm here again. In a normal field study, I take a crosshatch pattern of samples 200 feet apart, in rows 200 feet apart, so you end up like with a checkerboard pattern, and you have a nice set of samples to work with. There's always some rogue samples in there that are abnormally low or abnormally high, but when you have that grid pattern, you can pick those out and make sense of the survey a lot easier than you can just running a line of samples like we are here. This is not a sample pattern I would use to stake a well on or anything, but for the purposes of demonstration, it seems to work pretty good. There it goes. I'm going to go ahead and extend the timer again because that came so late. We're only 30 points from the alarm threshold, so obviously we picked it up again. I don't know if we'll get any further strength out of this sample point or not. Give it about 15 more seconds. I work with the bottom numbers, obviously. The difference between 3567 and 3600 where the alarm trips is very minimal. So really it means the same thing, but the alarm will only go off at a certain number. So we'll get kind of straight west of this guy and maybe make one more scan and then get back off feature again, just to prove that we're working here. And let's see, and here we go. Seconds to go. There it is again. Just stopping short of that timer. There we go.
Hydrocarbon reservoir detected. Hydrocarbon reservoir detected.
This is going to be another good reading.
Hydrocarbon reservoir detected. Hydrocarbon reservoir detected. Hydrocarbon reservoir detected.
So we've got two readings here, two very robust readings here that tripped the alarm, and one that fell 30 points short of tripping it. So now I'm going to run up here where there was actually a dry hole. Pretty close. Certainly more than a location away from that well now. So we will restart a scan here, and I bet we don't set any alarms off up here. There is a lot of hydrocarbon extending across this entire tract here. Multiple pays have produced in here, so I would expect to get some weak readings about anywhere in here. Definitely pretty cool when you can go out and drive up to that well, drive away from it, drive back up to it, get repeatable results, and also get strengths that help you determine where the thickest oil column is over that vertical sample site. So we got a ping there, but it's not going to be of sufficient strength to trip the alarm. So that tells me that there's some type of a very weak, well, not very weak, a weak. If you look at the red arrow, it's in between the weak and the moderate range. Catch one more up here, and again, it should not reach that productive range. Starting to contact people here in the next couple of weeks. Certain clients have expressed interest in our technology before, but are a little skeptical as to whether it works. We're going to be inviting them to go out, ride with me. We can either go to some wells and features that I'm familiar with, or we can they can wait till I'm in the truck and they can tell me where we're going. As long as we have some geological information that tells us where we should see something and where we shouldn't. I don't care if it's my demo wells we go to or theirs. Seconds to go. I'm going to be super brave. We're going to end this at 2700, which is barren. We're going to go back one more time to that producer just so I can solve any other doubts that are out there. Get up there within a couple hundred feet of that thing. And we should pick it up right here, I would hope. Okay, starting the scan. This is also great for road studies because it's immune to power line noise and other influences along the road, so we can run roads looking for features that are either crossing the road or that are adjacent to the roads. If you look at an oil map, you can see pools that, you know, do cross the road, especially sand channels, like Simpson sand channels down south of Wichita running a north and south orientation, so you would want to run road surveys east to west and try to intersect those. And then there's anticlinal features and structural bumps that you can often pick up adjacent to the road. I may be too close to this unit. I should have had a better response. I'm going to go ahead and... Ooh, there it went just as I touched the...
Reservoir detected. Hydrocarbon
So there's that 3800 again. That's an excellent reading. I was just about to hit the timer extend because I didn't think we were going to get it.
Hydrocarbon reservoir detected.
So we're going to end this scan at, I reset it there, it ended at 3850, so.
Hydrocarbon reservoir detected. Hydrocarbon reservoir detected.
Alright, be quiet.
Hydrocarbon reservoir detected. Hydrocarbon reservoir detected. Hydrocarbon reservoir detected.
Catch another one over here. Got to remedy that alarm. It even gets on my nerves, and it's me. Repeatability is everything. To be able to take multiple readings around this well, catch the anomaly, then go up there on the south end, read nothing, come back here, get repeatable results. That's everything with this, you know, with any technology. And not every sample repeats properly. There are, like I said, there are always some rogue samples, but when you're doing a crosshatch pattern, you can identify those, because you may have a cluster of 30 samples and 25 of those are anomalous, and maybe 5 or